Hi, my name is Jackson, and this first section from the Altitude Trigonometry book is called the sets of numbers. Now, in previous years of mathematics, you may recall that we did give categories to differentiate between different types of numbers, such as like positive, even, odd, irrational, rational. But in this section, we're going to go further into that and talk about the true nature of these categories. Now, the overarching category of the sets of numbers would be complex numbers. Now, complex numbers are divided into two subcategories. Those would be real numbers, what we call just integers, irrational numbers. It could be two, whoops, hold on, 3/4, 0.3 bar, etc. And imaginary numbers. Now those we're going to get into a bit later in this book, but for now, just understand that it's what you get when you take the square root of a different number. For example, if you take the square root of -4, in previous years we'd say that you couldn't do that. You can't take the square root of a negative number, and you can't in the set of real numbers. But in the set of imaginary numbers, we call that 2i. So for the majority of this section, we're going to talk mostly about the set of real numbers. Now, in the set of real numbers, what we know is there are three subsections from that. Those would be negative numbers, the number 0, which is neither positive or negative, and positive numbers. Now, all of these can be divided even further into rational numbers and irrational numbers. Now, the definition of a rational number is a number that can be expressed exactly as a ratio of two integers. For example, 4/5 would be a rational number, or 2/3, 1/3, even 2, just 2 over 1. That is a rational number. Now, irrational numbers are numbers that we can't express as a fraction. That would be, for example, the square root of 2. That cannot be expressed as a fraction. The cube root of 11, and repeating decimals, such as the number pi, 3.14159, that goes on forever. So that we call an irrational number. So now we're going to delve a little bit further into irrational numbers. Now, there are two main types of irrational numbers, and those are what we call radicals and transcendental numbers. Radicals I kind of talked about before when I was talking about irrational numbers. Those are anything such as like root 2, anything that involves a radical. Root 2, root 5, the cube root of 11, and so on. Transcendental numbers are special numbers that cannot be expressed as roots of integers. A couple examples of those are pi, which I'm sure you're familiar with. Maybe one you're not familiar with is the number e, and that's something you'll get more into in pre-calc and calculus. But those are the main types of irrational numbers. So now we're going to go into a little bit further into the set of rational numbers. Now, again, a rational number is a number that can be expressed as a ratio of two integers. From that, we have two subcategories of rational numbers. Those would be just integers, as well as non-integers. So an example of a couple integers, I'm sure you're familiar with this, but just any whole number, number 2, -3, 2001, and so on. Non-integers, on the other hand, would be fractions, like numbers between integers. For example, 3/4, 1/2, 2/3, and so on. So going even further into the set of integers, there are 4 different subsections of integers. Those would be the natural numbers, or sometimes called counting numbers. Natural. The digits, the even numbers, and finally the odd numbers. Now the natural numbers, which are are also called counting numbers. Now those are the positive integers. They're called the counting numbers, obviously, because they were the first numbers invented, the ones that were used to count with. Now those are any positive integer, so 1, 3, 500, and so on. The digits are only the numbers 0 through 9. The reason we call them the digits is these are the numbers from which numerals are made. So it's any number from 0 to 9. The even numbers are any numbers that are divisible by 2. For example, 4, 16, and so on. And the odd numbers are the integers that are not divisible by 2. For example, 51, 19, and so on. So to summarize, the set of all numbers is classified as complex numbers. Those involve a real part and an imaginary part, such as a plus bi, where a is the imaginary part, or a is the real part and b is the imaginary part. So 2 plus 3i would be a complex numbers. From that, we can categorize them as real or imaginary. From real, we have negative, 0, and positive numbers, all of which can be classified as either rational or irrational. The irrationals involving radicals like √5, √2, or the transcendental numbers such as pi or the number e. From rational numbers, they can be divided into either integers or non-integers. Non-integers are numbers that are expressed as fractions, such as 3/4, 2/7, and integers are numbers that we don't express as fractions, and those can be classified even further as either natural, digits, even, or odd. The natural numbers are the or counting numbers. Those are all positive integers, so 1, 2, 2000, and so on. Digits are the numbers 0 through 9. Even are any number that is divisible by 2, and the odds are any number that is not divisible by 2. And this whole table you can find on page 1 of your textbook if you want to look at it further. Okay, so we're just going to do a little practice with categorizing numbers. Now, I took a section of this table that you can actually find in your book on page 3. So basically, we're given a bunch of numbers under the field of complex numbers, and we're gonna just go through and categorize them in these different categories. So starting with the number 5. Now, the number 5 is an integer because it is a whole number, and it's a whole positive number, so it fits into the category of integer. It is a digit because it is from 0 through 9. It is not a negative number, obviously, and it's not an imaginary number. And it's also not a transcendental number, which again is a number that cannot be expressed as a root of an integer. Now going next is 2/3. Now 2/3 is a part of a whole number, so we don't classify that as an integer, nor do we classify that as a digit. It is not a negative number, it is not an imaginary number, or a transcendental number. Well, we would classify it as a rational number, but I just did not include that section in the table. Now, the number e, that, remember, is something that you probably haven't seen before, but it It is used more in pre-calculus and calculus. But it is a transcendental number. It is a number with a decimal repeating forever, and it cannot be expressed as a fraction or a root of integers. The number 44 is an integer. It is a positive number. So remember that integers are the positive and negative whole numbers. It is not a digit because it's not from 0 through 9. It's not a negative number. It's not an imaginary number or a transcendental number. But it would be part of the real number category and, of course, the complex number and the even numbers. 1/9 is not an integer. It is not a digit. It is not negative. It is not imaginary. And it is not transcendental. So we won't check any of these, but it would be a rational number. The square root of -16 is not an integer. It is not a digit, and it's not a negative number, even though you see the -16, because the negative number only applies to those that are real. The square root of -16, though, is an imaginary number. -2 is an integer. It is a negative whole number. It is not a digit because it is not from 0 through 9. It is a negative number. It is a real number, so it's not an imaginary number, and it's not a transcendental number. The square root of 2 is a number that has a repeating decimal, so it's not an integer. It is not a digit. It's not a negative number, nor an imaginary number, or a transcendental number. It is, on the other hand, an irrational number, and of course it fits into the category of real and complex numbers. So this concludes section 1 of chapter 1 of your textbook, and I'm sure we delved much deeper into categorizing numbers than most people would enjoy, but in any case, I hope this helped, and I hope it all goes well.